Hello everyone, welcome back again. So my dear friends, today in this video I want to discuss some passing hacks of applied physics for mechanical stream. As you already know that VTU has changed the syllabus for this particular subject for every branch. So its subject code is BPHYM, that is for physics for mechanical stream, first semester second subject and second semester second subject. Okay, so let me tell you my dear friends in this video which are the passing modules over there which you have to focus so that you can easily what we call pass this subject, conquer this subject with ease. So without wasting any time, let me start with the module first over here, as this is the passing module. First passing module is the module first over here, that is oscillations and shock waves. You might be aware of the what we call as oscillations like simple harmonic motion, as it is the 12th class based concept over there. So first question is, which is a definite question over there, that is what is simple harmonic motion, and write the differential equation for SHM. This time they have given in the syllabus there is no derivation for this particular SHM over there. Actually in the previous syllabus derivation was important over there, but this time they have deleted this derivation. So focus on this simple harmonic motion definition and write down the differential equation. Simply you have to write down the differential equation. Okay, so next one is the characteristics of shock waves and applications of the shock waves. Okay, next one is construction and working of ready shock tube with neat sketch. Focus on this much this question, my dear friends. This is most important question as far as previous papers are concerned, as it was in the also 2018 scheme continuously asked in the VTU examination, that is construction and working of ready shock tube with neat sketch. You can also refer 2021 paper, also 2021 scheme. It will be there in this in the question paper. Next one is, what are the forced oscillations? Obtain expression for displacement and amplitude of the forced vibrations. They will ask like sometimes what are the forced oscillations. Mostly they will ask obtain expression for the amplitude of forced vibrations. This is very least chances are for this particular expression, that is for displacement over there. So but you just focus on both parts, that is displacement and amplitude of forced vibrations. Next one is the series and parallel combination of springs. Derivation is there, you have to focus on the derivation part over there, series and parallel combination. Theory of damped oscillations, types of damping like critical damping, over damping, under damping. Okay, so focus on those parts only, theory of damped oscillations. Okay, next one is the engineering applications of the damped oscillations, and also some definitions like Mach number and Mach angle, resonance and sharpness of resonance, and stiffness factor. This much content is enough, my dear friends. If you just cover theory portion, you will at least get 10 15 sorry 15 marks you will easily get. But I will prefer you just try some simple problems also from this module, as these are the simpler ones. So go through series and parallel combination like problems over there, and on also on the basis of simple harmonic motion. So it will be easy for you people to get 20 marks in this particular module, as I have mentioned above, as it is the passing module over here. Okay, so you have to focus on this part. Next one is module second, my dear friends. In the module second, elasticity, it is also a 12th class based concept. You might be known about what we call the Hooke's law, Young's modulus, like rigidity modulus, and Poisson's ratio. Okay, so all about you have read about in the PU classes. Okay, so most important question is the derivation over there, that is the relationship between Young's modulus, rigidity modulus, and Poisson's ratio, where symbols have their own meanings. It will be the question over there like that. So another one is, actually there is also another derivation which was in the 2018 scheme, bulk modulus, Young's modulus, and Poisson's ratio, but this time they have not mentioned it in the syllabus. They have simply written over there, mention the equation. You have to only mention that particular relationship over there, no need to derive the equation. So you have to derive only this Young's modulus, rigidity modulus, and Poisson's ratio. Next one is stress strain curve, explain Hooke's law. Okay, so this is important question. You have to draw what we call the stress strain curve. It is actually a graph over there. You have to show like what we call as yield point and upper limit like that. Sorry, yield point, lower yield point, and maximum stress, ultimate stress, and tensile like that you have to show in the curve. So that is the stress strain curve, and you have to explain Hooke's law. Okay, if you want some problems also, if you want some derivation videos, you can comment down so that I can make separate video for them also. Okay, next one is define bending moment and derivation of the expression. You have to define bending moment and derive the expression for the bending moment also. Okay, so these are the three important main questions from this particular module over here. Then some definitions which you have to focus on. Okay, these are not, I'm telling you, the most important questions, but you have to be mature to answer these particular questions. That is Young's modulus, like Poisson's ratio. Already you have derived equation in the upper part, that is Young's modulus, rigidity modulus. So you should be know about the definitions also, like elastic modulus, Poisson's ratio, limiting values of Poisson's ratio. Okay, right. Then failures of engineering materials, like ductile fracture. They will ask you what is the ductile fracture. Write down the note on brittle fracture, stress concentration, and fatigue and factors affecting fatigue. Okay, and stress hardening and softening. Only definition part, stress hardening and softening over there. So this is the theory part in the module second. If you want to pass this, if you are focusing on the passing marks over there, so this much content is enough for the module second. Then module 5th comes up, as this is the one of the passing modules also. Module 5 is the passing module, as it contains all the theory concepts over there, that is a material characterization and instrumentation techniques. But you have to draw neat sketch over there. If you just draw neat sketches, then you write you in your own words whatever you write. But first of all, you just understand concept in your own language, then you can write some what we call as points on these particular diagrams over there. Suppose first one question is the, with neat sketch write the principal construction and working of X-ray diffractometer. Okay, this is important question. You have to try try to draw diagrams and then write the principle and construction and working. Okay, next one is the working principle and construction of atomic force microscopy, that is AFM. Write its applications. Okay, sometimes they are giving only the applications of the atomic force microscopy. Okay, but you just focus on also working principle and construction part. And then explain X-ray photoelectron spectroscopy, that is XPS. Next one is explain scanning electron microscopy, that is SEM. Explain transmission electron microscopy, that is TEM. Next one is the crystallite size determination by the Scherer equation. Okay, so on the on this basis they will ask some problems also. But if you focus on the what we call the theory part over there, at least you will get 15 marks. So just 15 marks are just in your pocket, and sometimes if you are lucky, then 20 marks also can be in your pocket over there. Okay, if numerical problems are possible for you, if this is convenient for you people, so go through. If you find difficulties, then leave it. You can leave it easily. You just focus on the theory part over there. Then module 3 comes up, as it is the thermoelectric materials and devices over there. So focus on the this part with the neat sketch. Write down the construction and working of thermoelectric generators like TEG. Okay, and thermoelectric coolers, TEC. Applications also you have to mention over there. Next one is the expression of thermo EMF in terms of T1 and T2. Then laws of thermoelectricity you have to focus on, and what is Seebeck effect, Peltier effect. Mention Seebeck and Peltier coefficients over there. Then thermoelectric materials, low, mid, and medium and high, and write their applications. So these are the concepts which you have to cover in the module third. As you already know, my dear friends, syllabus is very vast over there. I know you cannot cover all the syllabus in just these days, as you have already third internals pending yet. So you have to focus on this much content. Then also one question is there, that is exhaust of automobiles and refrigerator space program, etc., and some numerical problems if convenient. Okay, then module 4th, that is cryogenics. That is first one question is the, which is the most important one, that is Joule-Thomson effect with 3 cases, and porous plug experiment with theory. Next one is the thermodynamical analysis of Joule-Thomson effect, then Lindy's air liquefier, platinum resistance thermometer, and applications of cryogenics in aerospace tribology and food processing, liquefaction of helium, liquefaction of helium and its properties, liquefaction of oxygen by cascade process. So this is enough content in the model 4. So as I mentioned, whatever I mentioned in this particular video, my dear friends, go through these concepts. You will easily pass this subject.